Have you ever stopped to think about what happens when an AI breaks? Today, we're diving into a huge shift in how we build and maintain artificial intelligence. We're moving away from these fragile, high-maintenance models and into a new era of AI that can actually heal itself.
But first, let me just throw a number at you. 88%. Any guesses what that could be in the world of AI?
Yeah, it's the failure rate for corporate AI initiatives. We're talking nearly 9 out of every 10 projects just never make it. They get stuck as science experiments in a lab and never actually deliver any real value. That is the massive problem we're going to solve today.
So that leads us to the million-dollar question, right? How do you stop your AI from becoming just another statistic? How do you build an AI that not only works on day one, but keeps working, keeps adapting, and can even fix itself when things inevitably go wrong? Well, to answer that, we've got to first understand the old way of doing things. The root cause for why these super intelligent systems are, ironically, so incredibly fragile. The best way to think about it is like this: a hand-built supercar versus a modern factory assembly line. For a long time, an AI model was like one of those bespoke hand-built cars. I mean, it's impressive, right? A total marvel of engineering, but it's an absolute nightmare to maintain and repair. One tiny change in the road conditions and boom, it breaks down. The new way, it thinks like a factory, standardized, automated, and built for reliability and scale. And that factory, that robust assembly line for artificial intelligence, it has a name: MLOps. And this is the solution to that crazy 88% failure rate. So what the heck is MLOps, really? At its heart, it's the bridge, the handshake, that connects the brilliant data scientists creating the models, that's the ML part, with the rock-solid, scalable world of IT operations, the ops part. It is all about automating and standardizing the whole shebang, from the moment a model is born to its deployment and beyond. So what makes this factory actually work? Well, it's built on a few core pillars. You've got automation, which just gets rid of all those slow, error-prone manual steps. Then there's CI/CD/CT, which includes continuous training. This is so important because it lets models automatically learn as the world changes so they don't get stale. Next is monitoring. I love this one. Think of these as smoke detectors for your data, catching problems before your users ever see them. And finally, governance, which bakes security and compliance right in from the start, instead of it being a last-minute panic. Okay, so what happens when you put all these pillars together? This is where the magic happens. You don't just get a more efficient process, you get a system that can quite literally heal itself. Just look at the difference here. In the old world, how do you find out your model is broken? You wait for angry customers to complain. Then a data scientist has to drop everything, manually retrain it on their laptop, do a few spot checks, and just hope it works. But with MLOps, real-time monitoring catches the error instantly. An automated pipeline kicks in and retrains the model. It's then rigorously tested against the old one and rolled out with zero downtime. I mean, the difference is just night and day. But this MLOps factory is even smarter than that. It doesn't just have one hammer to fix every problem. It has a whole toolkit, and it knows exactly which tool to use and when. Okay, this is super important. Knowing the difference between retraining and fine-tuning. Retraining is all about teaching the model new patterns from fresh data. Think of a stock prediction model that means to learn from last week's market changes. Fine-tuning, on the other hand, is about changing its behavior or its personality. For example, teaching a general chatbot to adopt your company's specific brand voice. And the best part? MLOps can automate both. And check this out. What if the model is fine, but it's just not quite smart enough for one specific tricky question? That's where automated model routing comes in, and it's so cool. The system can first try a fast, cheap model. If an evaluator system flags that response as low quality, bam, it automatically reroutes the exact same prompt to a more powerful, smarter model. All of this happens in milliseconds, and the failure gets logged so the system keeps getting better. That is self-healing in real time. So, with all these incredible tools at our disposal, the next logical question is, how do you know which one to pick for your problem? Here's a really simple framework you can use. If your AI needs to know specific facts from your private documents, you'll want to use RAG. That's Retrieval Augmented Generation. It lets the model pull in real-time info from your unique data to answer questions. If you need your AI to adopt a certain behavior or persona, then fine-tuning is absolutely the way to go. And if the fundamental statistical patterns in your data have shifted, that's your cue that you need to retrain the model. Choosing the right tool is half the battle. Now, you might be thinking, hey, Can't I just use the latest and greatest model from a big cloud provider? Well, here's the reality. They don't have your internal emails, your confidential spreadsheets, or your proprietary customer data. You still need an MLOps pipeline to connect these amazing general purpose models to the specific data that makes your business, well, your business. And that ultimately is the biggest takeaway here. MLOps is what transforms a cool AI experiment, a fragile little project, into a durable, scalable, and self-correcting business asset that generates value day in and day out. So I'll leave you with this question to think about. When you look at the AI initiatives in your world, are they those beautiful, hand-built cars that are just one pothole away from the repair shop? Or are they built on a factory assembly line, ready to adapt, ready to scale, and truly built to last?